Welcome to Yaka Digital Network videos. Data serves as the evidence we use to map and understand our physical world. It translates simple observations into measurable facts. Government planners rely on this information to determine where to build new clinics, just as business owners use it to track their daily sales figures. But the physical world is often chaotic. If you look at a busy marketplace, it is difficult to measure the activity accurately through casual observation alone. Translating this complexity into an actionable mathematical model requires a structured process. We manage this translation using the four-step data lifecycle. Step 1 is define. We must determine the specific question we are trying to answer before we begin looking at numbers. Following this cycle sequentially provides a system of checks and balances that guards against errors and manipulation in the later stages. Over the course of this video, we will build a statistical model from the ground up to demonstrate how accurate data is formed. Handling data is a structured approach used to distill objective facts from the messiness of the physical world. Once the question is defined, we move to step 2, collection. This involves gathering the raw information needed for our study. This information comes from two origins. Primary data is collected firsthand through interviews. Secondary data comes from pre-existing sources, like government reports. In statistics, the population refers to the entire, complete group of individuals or items you are interested in researching. However, it is rarely possible to survey an entire population, such as every citizen in Uganda, due to constraints on time and resources. To solve this, we use a sample, a representative fragment that stands in for the whole population. Random sampling gives every individual an equal chance of selection, which is the standard method for avoiding bias. Alternatively, stratified sampling ensures the sample is proportional to specific groups, such as ensuring each grade level in a school is represented exactly. Collection also requires careful human design. The way a question is phrased can accidentally force a biased answer. A leading question, like, "Don't you agree that pasho is the best meal?" pushes for a yes. A neutral question asks, "Which of these meals do you prefer?" and uses clear units like kilograms or years. The accuracy of your final results depends on the elimination of bias during this initial collection phase. Next is step 3, organization. A pile of raw, unbiased data is difficult to use until it is structured. Consider a researcher organizing a mixed harvest of common Ugandan crops. We begin by tallying, a visual method of counting individual items as they are observed. These tallies provide the frequency, the specific numerical count of how many times a distinct value appears in the set. We then transfer these counts into a frequency distribution table. In this table, you can see how the visual tally strokes for matoke match the final frequency number. This table acts as the essential bridge between raw field observations and visual charts. It is important to distinguish between categorical data, like types of fruit, and continuous data, such as exact weights or heights. Skipping the organization step often leads to mathematical errors when you attempt to display the data. Organization is the filter that cleanses raw observation into structured evidence. The final step is display. This is the process of translating frequency numbers into geometry that can be understood at a glance. The tool you choose depends on the comparison you want to make. A bar chart is the best tool for comparing individual quantities of different categories. A pie chart shows parts of a whole, where the full circle represents 360 degrees. However, visual displays can be used to mislead. In this chart, a small difference between two values looks like a massive leap. This is caused by a broken axis that starts at 100 instead of 0, which manipulates the viewer's perception of scale. When we re-anchor the y-axis to 0, the bars return to their honest scale, revealing that the difference is actually quite small. A chart without clear labels, an honest scale, and a key is just a drawing, not a tool for evidence. It is also vital to distinguish between a bar chart, used for categories, and a histogram, which is used for grouped continuous data. Visual integrity requires strict adherence to mathematical reality. If the scale is altered, the objective truth is entirely obscured. The full cycle is now complete. We defined the question, collected an unbiased sample, organized the tallies, and displayed the results honestly. Drawing a perfect graph is the technical requirement, but it is not the final goal of data handling. Success in examinations requires you to interpret data, moving from simple descriptive drawing into analytical thinking. You must be able to identify the trend, the general direction in which the data is moving over time. You also need to identify the mode. This is the most frequent number in the set and is a key marker for understanding preferences. Consider how external factors change these results. A survey about student transport taken during the holidays will produce a different mode than one taken during the school term. Data provides the mathematical evidence required to tell an objective story about the world around us. Whether you are a student, a farmer tracking harvests, or a leader planning infrastructure, data literacy is a vital life skill. Always ensure your samples are fair and your visual labels are explicitly clear to maintain the honesty of your work. You can watch more videos for all classes here and get all content at www.yaka.cc.